Hello and welcome. My name is Aaron Clark. I'm a principal data scientist at Biogen. Today we're going to be talking about tracking Shiny app usage, basically just a review of tools. And this is presented at the West Michigan R Users Group. Today, July 12th, 2022. So without any further ado, let's jump into this content. So first and foremost, I thought we should start by talking about user adoption. And I framed one person's definition of user adoption here. So I'll just read it aloud. User adoption, sometimes just called onboarding, is the process by which new users become acclimated to a product or service and decide to keep using it. So users only adopt a product if it helps them achieve a goal of theirs. And this is from Jenny Booth from mixpanel.com. I thought that was particularly useful in framing today's topic. And why should you care about that topic? Well, it's because as a Shiny developer, we spend tons and tons of time curating these beautiful applications that are designed to hopefully accomplish a goal, hopefully your user's goal. Sometimes we fall short of that, but I know that we spend so many times painstakingly making the user interface as user-friendly as possible with the correct colors and the correct visualizations and everything framed in its way so that it makes sense. But sometimes that doesn't work out in the end because people stop using the app or people don't even open the app. The users aren't getting the value they thought they would be getting out of the app. And so I think that there are a number of reasons why this could be. Possibly you misunderstood your stakeholders' goals or needs from the beginning, or perhaps maybe the app achieves their goals, but it's just too difficult to get to the end result. That may be the case, but I'm sure that there are many, many others. Let me hide that. Maybe it means that we need to go back to the drawing board, reassess our approach. Either way, I think that a good strategy to follow is that of Hadley Wickham's. He always preaches to help users just fall into a pit of success. And what he means by that is like have the user experience be designed in such a way that users can't help but do it successfully. They can't help but reach their goal because things are designed in such a way that you can't mess it up or you can't. So how are we going to do this? Or at least I propose that we measure. So what do I mean by that? I'd say before that you start embarking on a new project, make sure you sit down with your end users and understand all of these needs. So they have different motivations, they have different needs, environments, beliefs, and complaints about a current process or something of that nature. And I'd even recommend after project launch to keep assessing these things on a continual basis. Because to measure these things is to know and understand what your users need. But let's say that you have limited communication with your end users. That it can oftentimes be the case, especially if you are working with an open source project. Maybe you don't have access to user feedback, or let's say you do have access to user feedback, but for some reason you're just not getting the whole story from your users. And I would argue that you likely aren't. At least that's been my experience in the past. So enter Shiny app usage tracking. So I believe that every app should have some form of usage tracking so that you can answer questions that are framed like this. Is my app even being used? How many users are there? Is a specific person using my app, like the CEO? How often are they using it? How long are they using it? Which features or workflows are being used the most or the least? Does that align with my expectations, and do I need to enhance the user friendliness or certain widgets to increase adoption of these new features? And do I need to spend a little extra time marketing my application to different target users, or maybe just marketing certain features? Being able to, if you can answer these questions, then wow, you're going to have a good grasp on how the users are using your application, which can inform what you do next as a developer to make the experience oh so sweeter. and just in general driving value for your organization or for your users. Okay, so today is basically just going to be a review of tools. There are many, many tools which can help you answer these questions. And after today is finished, I hope that we can gain a general working knowledge of these tools listed here. So Bitly, yes, so simple. Very, very simple solution. Bitly, we're going to talk about that. Google Analytics, Matomo Analytics, Shiny Logs, Shiny Stats. Shiny Logs and Shiny Stats are our packages. And then there's also RS Connect instrumentation data. And that's also going to be an R package to review as well. So I want you to know when and where to use each tool, and I hope that you just feel encouraged by the end of the talk so that you can be excited and want to dig in and use one of those, or two or three of those. Okay, so starting us off, let's take a look at Bitly. So if you know about Bitly, you know that this is simply just a URL shortening tool. But what's cool about it is it also counts URL clicks. So why would you want to use it? Well, you can know if users are actually opening the app. They're clicking on the link and using the tool. It's also great for conferences. I found I use it a ton, especially if I'm demoing like a live app to the audience that they could have access to. I'll send out that link just to sort of measure, audience engagement. And I think it's helpful elsewhere. So like if you are sharing documentation with folks, maybe you can see that, 100 people clicked on my link to the application, but only 15 actually opened the documentation. So that's actually going to provide you with a little bit more information about how many people are really digging in deep and trying to understand the application and how certain components work. So I'd highly recommend using this for public-facing URLs, since your internal organization, IT team probably isn't going to be excited about you uploading private URLs to a public site. And this is how you create one. So very, very simple. You copy and paste a long link. Doesn't have to be long though, it could be short, into their link shortener, and then you get to customize the back half. So that's nice. Customize the back half. So here's an example. I have a long link for an application currently hosted on ShinyApps.io, and it's called Idea Filter. So it gets shortened to bit.ly/demo idea filter. So that I created that custom URL, and I think this was sometime last week. I shared it, and it kind of gives you a day-by-day sort of progress of who's using the app, etc. So when I snipped this snapshot, 16 people, or at least 16 clicks had occurred. May not be 16 unique people. So that's actually useful feedback. Okay, so that was a simple solution. Now we're going to move forward into some more sophisticated solutions, such as Google Analytics. So Google provides a free service that collects information about basically who's visiting your site, and lots of people use it for SEO, search engine optimization. Best used when you have a public-facing app again, and then we'll talk about what you can use for an internal organization app in just a minute. So just getting started with Google Analytics, you can go ahead and create your account at analytics.google.com. And then all you need to do is find your tracking code for your website, or they call these properties. So the website is also known as a property. You're going to notice that there's two sort of scripts here that includes JavaScript code. So you first have this async source, and there's a Google Tag Manager URL here. And this URL is going to contain something called like your G code, basically. This is not a real G code. Yours will just be a bunch of numbers. But that's going to be your unique tracking ID for your site. So this is going to kick off anytime the site is opened, and that's why they use this keyword here, async, because they don't want to slow down the startup process of your website. Secondly, there's a script that basically is going to record the date and time whenever the app is open. So that's what this second script does right here. So if you don't know JavaScript, it's totally fine. You don't have to. They give you this code. All you need to do is plant it in your application. Oops. Okay, so next up, add this to the app. So they recommend adding it somewhere in the head of your UI. So if you're not familiar with how to do this, you can use the Shiny tags head syntax seen here, and you just load the two scripts. So the first one is going to be that it's going to source the Google Tag Manager.com, and you're just going to make sure that you include the async argument with empty string. And then the next one is going to go right into basically run a static script that you've stored maybe in your www folder for your application. And that's it. So all you need to do now is redeploy and test the application. So after deployment, just a quick note here, you're going to want to visit the site, and then you'll have to wait maybe a little bit, a max of 1 to 2 minutes, and then the data will start streaming into the Google Analytics report. And so you can see here that I did this for another application that I manage that's public facing. It's called Tidy Disk. And I just did a proof of concept. I clicked on it twice, and you can see here that it totally logged those clicks. So now I know how many views that page is getting. Okay, so now that just tells you how many people are visiting your site, and it may also tell you like the IP address for those folks, but something that it's not doing is tracking certain events. So this requires a little bit more JavaScript knowledge, and to be honest, I'm not probably your best JavaScript expert to lend a hand or teach you anything new or specific about this. But let's just dive in to give you an example. So let's say that you have the following drop-down input. And this input actually exists. It's from the Forest Rangers Shiny app that our friends at Epsilon created. So basically, you give it an ID, and you say, I want these to be my choices. So that's what the user sees. However, the values in the background are actually the scientific names of those trees. And the default text is just going to say tree species, and the initial value would be Douglas fir. So after you've created this application and you launch it, you need to find that element. And that's kind of like the first step, is you need to go out and find that element in your HTML browser. So they kind of took a shortcut, I think, in this example that they provided, because this function dropdown input actually generates a dropdown menu where each element has the class called item. So since that's the only dropdown in the app, they can basically call out this element pretty easily, and all they need to do is use the syntax here, $, quote.item, and that's jQuery syntax. Okay, so just a quick side note on if you're trying to find elements. Sometimes it can be tough, sometimes it could be easy, but a good way to get started is just to, in your browser with the app pulled up, for Chrome at least, I don't know how this works in other browsers, but for Chrome, you can actually just right click. So you're just gonna, this is the drop down input right here. You're gonna right click on that, and then you're gonna go down to inspect it. And that's gonna pull up this cool like developer console over here, where you can actually inspect all the HTML that exists on the web page. Pretty neat. So that's when you can start to weed through the HTML, looking for specific IDs or classes that you may be able to call out this drop-down input. Okay, so once you find it, so here remember we're using the we're looking for tree species, and we know that the class is .item. So this JavaScript code is basically allowing us to say whenever someone clicks on that, we want to grab that value, and we're gonna define it as a constant, and we want to pull in that value, whatever it may be, and then we're going to use this gtag function. Remember, that's the function that we use to send stuff to Google Analytics. And we want to call it species selected, and we're going to send it in this format. So if you do that, you can see that that information gets sent to Google Analytics. So if you look over here, you can see species selected, something was selected 7 different times, or maybe 8 different times, and here's the actual scientific values that were chosen. So that's useful if you want to know, like, what inputs are people really clicking on while they're using my application. But it does require some background in JavaScript, or at least learning some of the bare minimum of how you interact with that jQuery syntax. So moving right along, that's sort of Google Analytics as a quick, brief overview of how you can start to track things in your application beyond just who's visiting my site. But Matomo Analytics is exactly the same as Google Analytics, except for it is open source. So I like to recommend this one for organizations who want to have the same functionality as Google Analytics, but use it for an internal private application. So we're going to skip the how-to on this one because it's basically the same as Google Analytics. Okay, so next up is a package called Shiny Logs. This one gets a little bit more interesting and a little bit more native to the R ecosystem, which I think you'll probably enjoy a little bit more, especially if you're not a JavaScript user or coder. Okay, so what is it? It's a logging tool for Shiny applications. Basically, it's going to record inputs and outputs and the changes that they encounter, and also a lot of info about the user session. And we'll go into detail about all the elements that it kind of tracks. As a quick note, all the recording is done client side, so not to slow down the Shiny application or occupy the server. So it's available on CRAN. If you're interested, you can go ahead and install using install packages. Otherwise, if you want the latest development version, you can install it straight from GitHub. Okay, so how do you use it? Like, what's it like? What code do I need to make this work? It's pretty simple. So on the user interface side, all you need is one function called use tracking. There's no arguments to fill out. On the server side, there's a little bit more information to fill out. So there's track usage, that's the name of the function, and you just need to specify a storage mode. And so we'll actually get into all the different storage modes that exist, but I'd say the default or the most frequently used one is this one here called store JSON. You need to be able to provide a path to where you'd like to store these log files. That's the only real argument that you need to specify. Okay, so what's going to happen when this app is launched and starts recording information? It's going to record information about inputs, errors, outputs, and also session info. So for inputs, each time an input is changed, it's going to grab the name, the timestamp, the value. Errors, very self-explanatory. If an error occurs, it's going to log the timestamp and what the error actually reported is in the console. It's going to save that. It's going to tell you each time an output is regenerated, and then lots of information about the user's browser in session. Okay, so as far as storage modes go, we talked a little bit about store JSON. So basically, it's going to store the logs in separate JSON files, one per session. The next version or storage mode is store RDS. So we all know RDS files are like native R data files, and you can store those one per session as well. SQLite database, that could be useful for certain deployments, and we'll actually talk about which storage modes are best for certain deployments in a little bit, but I really enjoy using the SQL database, especially for storing lots and lots of information, log information. Store null is actually not going to store anything, hence the name store null, but it is going to print everything out to your R console. So one might think, hey, that might be useful for debugging, but I don't know. I thought through it a little bit. I haven't used it myself, but it sounds like it would be kind of overwhelming in terms of the amount of logs that would be printing to the console. But Nevertheless, it exists, so if you'd like to try it, feel free to do that. Store custom, so this is basically you can write a custom function to save the logs wherever you want. This can be really helpful, especially if you want to connect to maybe like an internal SQL database or something like that. And then last but not least, there's something called Store Google Drive, which is also pretty useful because it's cloud-based, which you'll find is very helpful for some deployments. Okay, so on that topic, let's talk about what storage modes you can use with each deployment. So from the Shiny server or RS Connect side, if you're on the Shiny server, you'll want to save logs on disk, but don't forget to set your write permission to the folder you want to save logs. So you'll just need an admin to basically give you those write permissions. On RStudio Connect, you need the absolute path to specify the directory where you want to save the logs. And there's a lot more information on that for your admin to review in this persistent storage article in the admin guide for RStudio Connect. Okay, Shiny Apps I/O, no such thing as persistent data storage. So you cannot use the JSON or RDS files because you have to use a remote storage method. So for example, you can definitely send stuff to Google Drive, or you can use Store Custom to send it to Dropbox or a remote database or something else. I didn't know this, but there is actually an entire package called Gargle that's committed to helping work with a Google API to work with setting your authorization for your specific account. So if you're interested in that whole Google Drive approach, definitely check that out. Okay, so Shiny Proxy, I'm not super familiar with deploying applications to Shiny Proxy, but I did just want to make note that there is a solution for that as well, especially if you're one that uses Docker containers and things of that nature. Here's some information that you may want to know. And it looks like you do need to specify that root folder in the file path directory. Okay, so now that we know kind of what storage modes we can use, what code we need, so what are we actually going to get from Shiny Logs? Like, what is the information that's going to be stored? So as far as session info goes, there's quite a bit. So I'll try to breeze through these really quick, but you're going to have the name of the application, the user, you're going to have the server connected time, the session ID, which will become helpful to sort of match between other tables. The time it was disconnected, your user agent, so it's your browser, screen resolution, browser resolution, pixel ratio, and that's time your browser was launched using the actual browser time, which depends on the user's time zone. So here's kind of an example output of what you might expect looking at your session data or your session table. So you can see here's the name of the app. It's called Iris Cluster. The user is Dreamers. That's when your server was connected. There's your session ID. That's when it was disconnected. And then you have some information about this person was using Mozilla, and there's more and more info beyond that. In terms of inputs, this is probably like, the bread and butter, right? We want to know what inputs our users are using and so on and so forth. So we get the session ID again for joining tables. We get the name of the input, so the input ID. We're going to get the timestamp of when the input changed and the value. And then there's also some things like type and binding, which we'll show here in the example. So here you can see that we have an ID for an input called xcall, and you may be wondering what kind of input is that. It's a Shiny select input, and you can see that it changed at this time, and the new value is sepal width. Similarly, there was an ID for a Shiny numeric input called clusters, and it changed at this time, and the new value is 6. So that's all very, very helpful information for understanding how your user is using this information. So I think that that's definitely one of the important tables. Outputs is a little bit, it's okay. The information isn't that exciting. And I say that mostly because you're really just getting the time that an output was re-rendered. So not that exciting, but basically here you can see you have an output called plot1, and it just says that plot1 was changed at this time, and it's a image output is what it is. Errors, very handy to know this. I remember in a past role, I would just get people emailing me on occasion saying like, hey, I don't know exactly what happened, but I was using the app doing this kind of stuff, and all of a sudden it crashed or something like that. But I couldn't reproduce the issue, wasn't sure what happened. It would be delightful to have some very, very specific logs that tell me what happened and what else was happening in the app when that error propagated. So here's an example of what that might look like. You can see the error occurred within your plot1 output. And here you can say it says NA foreign function call for argument 1. So that's at least helpful, gets you going in the right direction. So that's very, very valuable. Okay, that kind of wraps up Shiny logs. So now we're going to go into yet another another R package that logs user data. It's called shiny.stats. This is brought to us by Epsilon. And they claim that it's an easy way for logging users' activity. And this is kind of the fun part about shiny.stats. They also have some basic functions that create a dashboard for you to analyze those results. So that means that you don't have to spend a ton of time making some custom dashboard to sort of digest the SQL database and create your own dashboard. They've done it for you. So love that. I think that's super helpful. So you can install it from GitHub. I don't believe it's available on CRAN, but there is the installation step. And basically you need to start off by initializing like a SQLite database. So just note this, SQLite databases aren't going to work for ShinyApps.io because there's no such thing as persistent data storage. But basically you just need to form a connection, and you need to give the database a name. So here it's called user stats. And then that's how you disconnect. The one tricky part about shiny.stats is that you also need to define a function that basically can grab the username. So depending on your authentication process for the app that you're using, you're going to have to provide that function. So here they're using an application that stores the username in a URL. So they're actually going to just go out and parse that string, grabbing the username component, which is fine. But there are other ways to grab usernames depending on the deployment, again, and the authentication. So once you have that function, right, so that's called getUser. That's what they've called it here, getUser. So basically you need to use this function called initialize connection, and you provide your database connection in addition to a way to get the username. So get user and accepts an argument called session. And then you start to register different components. So here you can register the login. Here you can register a click on a button called apply slider. Here you can register an input that's changing. So this input is called bins. I believe it's just a slider that goes back and forth, and it's going to tell you what the values of that input are. And then at the end, you're going to want to for sure be able to log when a user logs out from their connection with the application. So that's basically the server-side logic, the functions that you can use in your app to start tracking things. So if you prefer, you don't have to use their whole, fancy dashboard. If you want, you can just use a SQLite database management tool. So I think this one's called Table Plus, and you can start to query that. Select star from user log. Or you can use their built-in dashboard. So here, this is all the code you need to run their dashboard. So you need to library a couple packages, create your database name and driver, create that get user function again. So it's going to return the username. And then look at, they have a function literally called shiny stats UI and shiny stats server. And the only things it needs is the get user function and your database credentials. And then you just run the Shiny app. That's all you do. And if you do so, it's going to produce something that looks like this. So I'm sorry it's not super big, but essentially it looks like they have some tabs for general stats, activity stats, user-specific stats, and sessions. It looks like they just initiated this app because the number of unique users is 1. They've only had 1 session. Average time is 2 minutes, and days of active use is 1 day. This is a cool. These are all cool graphs, but they're kind of boring because they don't have much data in them. But it tells you about average session time, unique users, and total clicks and inputs. So I think it would be really useful to check this out. And this is all toggleable to a certain time range, so you can enter a start date and an end date here. Okay, so that's basically it for Shiny Stats. We're going to transition to our next tool, and this is actually our final tool. It's called RS Connect Instrumentation Data. And so if we take a look at this, if you are a Connect user, you have access to this. It's called the RS Connect Server API. It comes automatically built in with all RS Connect installations. So you have it automatically, and maybe it's been collecting data for a long time, and now you just have access or knowledge of it. You should definitely go out there and try to analyze a little bit of it. So how do you do that? So there's lots of ways to do that, but first you need to start by installing this client-side R package called Connect API. If you want to learn more about the server API, there's some documentation here, and there's also a cookbook that you can reference. And just a teaser, so the Connect API is still sort of in an experimental state. It hasn't been out for very long. But a future goal of it is to make anything clickable in the UI can be mimicked programmatically via the API. So right now you can't do that, but in the future they certainly hope to do that. So the instrumentation data, what can it help us answer if we were to start ingesting and reviewing and exploring that data? It can certainly tell you how many reports are on the server, the users on the server, which users have access to which reports, who looked at a report recently, and reports are interchangeable here with Shiny applications. It just means content. And the RStudio team is working on lots of new features. They kind of have told us a few that they're working on, but I don't want to promise anything on their behalf. Okay, so all you need to do is library in the Connect API package, and you need to connect. Use this function called connect, and you just need to provide the URL for your server, and then you also need to include your super secret API key. Or if you have defined these elements in your environment variables, you can just run connect without any arguments, and it'll connect it. So once you have this client object built, either this method or this method, you can start to run these functions. So you can get users, get groups, get Shiny, get usage Shiny, get usage static, and get content. There's also this function called get content. If you want to get all the content, you can just say limit equal infinite. I should note that this says that you can get unlimited content or whatever, but your role has to be admin in order to access all the content. Otherwise, I'm sure most of you, including myself, have a role of publisher, which means that you can only get access to sort of your content that you've published in the past. So that's still useful. You don't necessarily need to ingest your entire organization's RS Connect usage, but you're just interested in your apps. So you can get the users. So this will give you their email, username, first and last name, and their role. If they belong to a group, this will give you IDs for GUIDs for the content and the user. It'll give you start and end times, and get static will do the same, but it'll just give you a single time that the static content was visited, like our markdown report. And then this get content tells you everything about the content. So the name of the content, the title, the description, etc. So let's just look at an example of that. For a Shiny app, if you're using get usage Shiny, you're going to get some data that looks like this. Pretty simple. Content good. If a user visited the site anonymously, like they weren't logged into RS Connect, you're going to get an NA here for the user good. Otherwise, you'll get a good, you'll get a start and an end time, and then you'll get some versioning. So this is a dashboard that you can actually plug your data into that's freely available on GitHub. You can look at RStudio Connect usage in the last 30 days. Pretty cool. You can see Shiny sessions by user, top 5. You can see Shiny sessions over time. Look here, you can see there's like over 100 Shiny sessions in a single day. Maybe they're hosting like some sort of application, or sorry, some sort of demo or some sort of classroom. And then you can also see top applications. So here's the top 5 applications, and I think if you hover over those, you can actually see the names of the files. There's also a Shiny app that they've built to sort of monitor the apps that exist on RStudio's RS Connect installation. And you can also have access to that GitHub repo as well if you wanted to run this application on your data. So here you can see the top 20 apps. Here you can see the top 20 viewers. A lot of them are NAs because they're signing in anonymously or using links anonymously. And you can also see the top owners, so the owners of these apps. And they did a pretty cool job here, just making like a little slider to hover over different time periods in the last 90 days. Okay, so we've made it. That's the complete review of the tools that I wanted to present today. So just to give a quick rundown of what we just talked about. We talked about Bitly, just a link shortener, tracks clicks. Google Analytics tracks people who visit your website. If you know JavaScript, you can track other things that happen on the site. Shiny Logs, very native and user-friendly, I think, to someone familiar with the R ecosystem. Provides lots of information, sort of by default, and I think it's probably my favorite. I think that I'm going to put a heart next to that. I think that's my favorite out of all of them. And then, that's kind of a weird heart. There we go. Shiny Stats, I think, is good as well. It can track quite a bit of information, and it has a user-friendly, like, little dashboard that you can use. And then there's the RS Connect instrumentation data, which you get for free by default whenever you're using RS Connect. So that's pretty cool. So I hope you feel encouraged to go and check out 1 or 2 of these tools, start using them for your organization or for your application that you're freelancing on or whatever it may be. Here's some resources that I used to sort of gather this information, and that's all I have to present. So thank you so much for your time and attention, and if you have any questions, I'd be glad to answer them. Thank you.